Hi, and thank you once again for joining me. Today we're going to continue our discussion about solving quadratic equations. And today we're going to get a fifth tool of the quadratic formula. So far we've been able to factor, we can solve by taking square roots, we can graph quadratic equations and find them on a graphing calculator, and we can complete the square. So today we're going to talk about the quadratic formula. So the quadratic formula is simply a formula that is derived by using the completing the square process that we just got through talking about. So if you use completing the square on ax squared plus bx plus c, just keep all those letters in there and use that completing the square process. You can come up with the quadratic formula, which is x equals negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So the nice thing about this is it can be used to solve any quadratic equation. So we're not really limited to just certain ones like factoring. There's only certain ones we can solve using that way because maybe they have an irrational solution. So we couldn't use factoring for one like that. I do encourage you to go and take a look at how this is derived by using the completing the square. If you can follow all of those steps, I would say you have a pretty good grasp on the completing the square process, and it gives you a better understanding of why this actually works the way it does. Okay, so let's get into a couple of examples of the quadratic formula here. So first of all, we're going to look at solve using the quadratic formula. In our first equation, it is 2x squared plus 12x plus 18 equals 0. In this one, I kind of color-coded everything for you so you can kind of see where everything fits. So here is our ax squared plus bx plus c. So a is 2, b is 12, and c is 18. And so what we do is we just take this and plug A, B, and C into it from here. The one thing I do encourage you to do is go ahead and write the quadratic equation for each problem the quadratic formula for each problem until you kind of have that memorized and can easily put everything in where it goes without having to refer back to that. It's just kind of something to get you used to doing that each time. Okay, so if we look, x equals, first one is the opposite of b. Well, since b is 12, we have negative 12 plus or minus the square root of b squared. So since b is 12, 12 squared minus 4 times a, which is 2, and c, which is 18. All divided by 2a, and again, a is 2, so it goes right in there. So the other thing I encourage you to do is try to write everything out first. Just put it in its place. Don't try to combine any like terms until you have everything written out, and then go ahead and start combining like terms and solving from there. Okay, so if we go here, first we need to kind of take care of what's underneath the radical. So 12 squared is 144 minus 4 times 2, which is 8, times 18, which is 144, all divided by 2a, which is 2 times 2, or 4. So we have negative 12 plus or minus the square root of 144 minus 144 over 4. Okay, well that 144 minus 144 happens to be 0. So underneath the radical in this particular case, we ended up with the 0. So negative 12 plus or minus the square root of 0 over 4. Well, the square root of 0 is just 0. So what we're going to notice is we're going to add 0. So negative 12 plus 0 over 4. And we're going to subtract 0. Negative 12 minus 0 over 4. Well, it doesn't matter if we add or subtract 0. We get the same answer. So we have x minus 3, x equals negative 3, or x equals negative 3. So they're both the same answer. So we call this one solution, even though it is it is a solution repeated. Okay, so here's what the graph of that kind of would look like. We would have our vertex on negative 3, and it would go up from there. So it would only touch the graph, or the axis rather. It wouldn't actually cross the axis which is why we're only getting one solution out of this. Okay, so moving on to another example. This time I took away the color coding, but hopefully you can follow along here pretty easily. So we have 4x squared minus 25 equals 0. So notice in this particular case, 4x squared is our a term, minus 25 is our c term. We don't have a plus bx in the middle there. So there is no x term to deal with. So in that case, b would have to be 0. So x equals, I've just written out the quadratic formula here, and now go ahead and start plugging things in. So since b is 0, negative 0 plus or minus 0 squared minus 4 times a, which is 4, times negative 25. This case, c is negative 25 because this minus sign goes with the number. So it's negative in here. All over 2a. And again, a is 4, so 2 times 4 on the bottom. So 0, and it doesn't matter if it's positive or negative, 0 is 0 either way. So 0 plus or minus the square root of 0 minus 16 times negative 25. Well, negative 16 times negative 25 is positive 400. So, and if you want, you can check that out in your calculator to verify. 0 plus or minus the square root of 400 over 8. Well, 400, the square root of 400 is 20. So it's plus or minus 20 divided by 8. And if we just simply reduce that fraction, we get, divide top and bottom by 4, we get plus or minus 5/2. So there is our two solutions for this one. Notice we have positive 5/2 and negative 5/2 as our solution. Notice we could have solved this one by taking square roots or by factoring the special case a squared minus b squared instead. We would have ended up with the same answer. So it doesn't matter which method we use, but since I'm doing examples of quadratic formula, there is an example of quadratic formula when you don't have a b term in the middle. Okay, next example. So we're going to use quadratic formula to solve 7x squared minus 11x plus 12 equals 0. So once again, we're just going to find a, b, and c, plug it into the formula. So b is negative 11, so negative 11 plus or minus the square root of b squared, well, negative 11 squared, minus 4 times a, which is 7, and c, which is 12. Forgot to close my parentheses there, sorry. Over 2 times a, which is, again, 7. So opposite of negative 11 is positive 11, plus or minus the square root of 11 squared, which is 121, or negative 11 squared is still 121, minus 4 times 7 times 12, which is minus 336, all over 14. So 121 minus 336 happens to be negative 215. So we have 11 plus or minus square root of negative 215 over 14. This does not simplify. Square root of 215 does not simplify. There's no perfect squares we can take out of that. But the negative we can take out and bring it out front as I. So we end up with 11 plus or minus I square root 215 over 14. Okay, so in this particular case, notice we have two solutions that are imaginary solutions. The plus and the minus here is what gives us two different solutions. Okay, next example. So next we're going to just simply use the discriminant. The discriminant is the part of the quadratic formula that is underneath the radical. And notice in each of our examples previously, that discriminant, or what's underneath that radical, kind of determines how many solutions we're going to have. Because if that square root is negative, we're going to have imaginary solutions. If it's 0, we're going to have a single repeated real solution. And if it's some other positive number, it's going to have two solutions. So from example 1a, our b squared minus 4ac was 0. So there was only one solution there. It was a repeated solution, but only one solution there, and it was a real solution. From example 1b, our b squared minus 4ac was greater than 0, so there was 2 real solutions in that case. And from our example 1c, b squared minus 4ac was less than 0, so there were 2 imaginary solutions, but no real solutions. Hopefully by now you've noticed with quadratic equations that since the power is 2, we end up with 2 solutions at most. Sometimes in that one special case, we might only have 1 solution, but remember that's a repeated solution. So in a way it's 2, but we only count it as 1 for purposes of this. Okay, so let's do a few examples of using the discriminants. So example 2, use the discriminant to tell how many real or imaginary solutions each quadratic equation will have. So for A, x squared plus 6x plus 9 equals 0. So here for our answer, we're just using the discriminant, b squared minus 4ac. So b is 6 squared minus 4 times 1, which is our a, and c, which is our 9. So 4 times 1 times 9. 6 squared is 36, minus 4 times 1 is 4, times 9 is also 36. So 36 minus 36 is 0. So you can tell, because this is equal to 0, we're only going to have 1 real solution there. Okay, for example B, x squared plus 6x plus 10 equals 0. So notice this is the only number that's really changed here. So in our b squared minus 4ac, we once again have 6 squared minus 4 times 1, and this time it's times 10 instead of 9. So 4 times 1 times 10 is 40. So we have 36 minus 40, which is negative 4. Since our discriminant here is negative, we have 2 imaginary solutions. So the discriminant is a really nice tool that we can use. If all we need to know is how many solutions we have and what kind they are, we can use the discriminant to do that. So that's all I have for you today. If you have any questions in class, please be sure to write those down and ask. And I hope you have a good night. We'll see you again soon.